All right, let's start building up our ALF1'26 chassis. First things first, some things to kind of keep in mind. We have front roll center bulkheads. There is +1, -1, and 0. I recommend starting with 0 as it is the most neutral steering. The lower you go, say -1, the steering is going to become sharper and more aggressive. +1, the steering feel will be more numb. Similarly to the rear end, we have rear roll center towers, so 0, -1, +1. I recommend starting with 0. Going down to -1 is going to be the most rear traction, and going up to +1 is going to be the most free feeling in the corner, as in not necessarily more steering, but more rear rotation. So for most people, 0 is going to be where you want to start. We also have 2 battery boxes. They're all intended for shorty 2-cell lipos. One is for the LCG shorty pack, and one is for a standard shorty pack. So depending on which pack you're running, you can choose which box works best for you. Chassis wise, we have one piece full length chassis. Countersinks and everything are already ready to go. Yeah, so let's start to get into it. First thing I like to do is build up the battery box. So for me, I just use a standard shorty. So I'm gonna grab 2 countersunk M3x8 screws, and in these rearward holes here, that's where we're going to mount the battery box. And then we have a removable electronics tray for the ALF1'26. So your speed control, your transponder, and your receiver all go on this tray. That way, if you're working on the car and you need to remove your electronics, you don't have to pull up double-sided tape. Same as the battery box, these use 2 M3x8 countersunk screws. And in the holes just forward of the battery box is where you're going to mount the electronics tray. I like to leave the screws a little loose. That way, once I get all the screws in place, I can go ahead and then tighten everything down. So you can see both screws are in, but the tray is a little loose, it moves around. So now I can go in and just do a final snug now that everything is located and squared up on the countersinks. Next thing, we can install the front roll center bulkheads. So like I said earlier, I'm going to start with 0. One thing I like to do is I like to cut. There's a raised sort of window here on both sides. This is going to be the rear facing portion of the part. I like to cut one of those pieces off, basically right in here, and that's so that the servo wire has a easier time. So now you can see basically cut that window out. So that side's still there, that side's cut open. The number tag should go towards the front of the chassis. So using 2 M3x22, I think these are M3x22. Yeah, M3x22 countersunk screws. We're gonna go ahead and mount the bulkhead with the forward holes first. Similar to the other screws in the chassis, I like to leave everything sort of loose until all the screws are in place, and then go through and incrementally tighten everything down. This M3x22 screw again is going in the forward hole of the chassis. Okay, and we'll take the second M3x22 countersunk screw, and that will go in the rearward hole on the chassis. so this thing's not quite tightened down. That's exactly what we want. Now for these 2 screws here, you kind of have the 4 open in the middle. We're going to be putting 2 M3x30 screws in the rearward holes. And yeah, these are super long. Luckily the M3x30s are not load bearing. They're just intended for the damper, silicone damper for the front single plane suspension. So although they're long, they rarely ever get taken out. Okay, so now that everything's in place and it's just barely loose, we'll go ahead and take our hand wrench and tighten everything down. Basically just like that. So I like to go in a cross pattern just to make sure everything's nice and square. And this is your front bulkhead and front roll center adjustment. So up next we can go ahead and install the battery strap. It's just a carbon fiber 3D printed battery strap, has the ALF1 logo on it. There should be a laminate carbon fiber option part available soon. To secure this guy down, we're going to use 2 M3x12 button heads. All right, so as we work more rearward, we can go ahead and put the rear bump spring mount in. That's this M3x35 countersunk screw. This screw again is not load bearing, so it's sort of just hanging along for the ride, and it's keeping the rear bump spring squared up. To mount this into the chassis, we're going to use a non-nylock M3 nut. All right, so now that there's like 4 or 5 millimeters showing to the bottom, we're going to go ahead and apply our Loctite. For most RC uses, I like to use purple thread locker. A lot of people don't necessarily know about purple. It's intended for screws that are under 6 millimeters in diameter. It's the same, you can buy it all in the same brands. It's just not as heavily advertised or carried by RC manufacturers. The breakaway torque on this stuff is a lot more manageable. You can over apply and not get screws stuck. So I think for the average guy that would actually probably be a little better. Definitely check that out. Something we've been doing for a long time and really like how that all goes together. So there's your rear bump spring. It's kind of just hanging out in space. That's okay. The rear spring is going to go over this when we get there. All right, so now we're kind of working on this middle section back here. This is mainly the rear roll center and the start of the rear pod mount. This is the rear roll center tower. So we need to do some prep work to this guy before we can actually install it in the car. And that's mainly installing the ball ends and the set screws. So with the lettering facing you, I like to start the set screw, and this is a M3x12 set screw, and basically we're just going to run this down to where the head of the screw is flush with the end of the part. Maybe leave a millimeter exposed. So that's going to leave you on this end, 3-ish millimeters, and that's what the threaded ball is going to mount to. So we have 2 screws to do that too. Okay. So again, 3-ish millimeters off the back side. The pivot ball that mounts to this is in 5 by 7 millimeter diameter. It has an M3 hole, threaded hole in the middle. So before we get those guys on there, we're going to go ahead and dab some Loctite on these exposed threads. Okay, and then this uses a the threaded balls have a 3 millimeter head. So we're just going to take those and thread those onto the end, just like that, and we'll do it 2 times. You don't have to really over torque these because you're using the plastic of the tower basically as the locking mechanism. So as long as you have some thread lock on there, just snug them down. You don't have to over tighten them. So now that this is ready to go, this piece here is the opposite mount. So this mounts on the rear pivot. I like to prep this part now since we're kind of already doing set screws and things, and it sort of is along the same lines of installation. So you can see there's a curved profile on this guy. The curved profile is going to face rearward towards the motor. This allows you to get a couple more teeth on your gear ratio. So keeping that in mind, we are going to take our two M3x12 set screws, and with the curved side facing you, start installing the set screw. So you can see here there's a couple millimeters exposed on the flat side of the mount. That's one, and then we'll do two. So we'll put thread lock on this guy. 1, 2, and then grab two threaded balls and put those on there. Cool. So this part we're not going to use right away, but I at least wanted to get the threaded balls on there and sort of get this prep since it's so similar to this component. We're going to go ahead and install the rear tower now. So it uses two M3x8 countersunk screws, and they will go in these two exposed screws. You can't see it. These two right here. And we'll tighten these down one last time. Cool. All right, up next we are going to install the side torsion links, and on the ALF1’26, these are your side springs. So there's not a physical spring back here. This entire link is the spring. The forwardmost hole is going to be for our body post, and then the straight inline 4 holes will be used for adjusting your spring rate. Typically we use either the second or the third hole. For asphalt applications, I suggest the third hole. For carpet, I suggest the second hole. First things first, we're going to install our body mounts. Actually, I'll take that back. Keep in mind, the side links are compatible left and right, but the bent ear is sort of what dictates what side it's on. So when you're assembling these with the body posts and things, you want to make sure that you are, building a left side and building a right side, and just keeping that in mind. So to put the body posts on, we're just going to use two M3x6 button heads from basically the bottom side. You're going to put the screw into the torsion bar, and the body post is going to go on top. So doing the left and right independently, you should end up with assemblies where the body posts are both facing upwards. So like that. Next up, we will put the ball inserts into the side torsion links. So you can see there's a large hole here. This is so that we can put a ball socket into the torsion bar, and then finally a threaded ball. There's two types of ball sockets on the ALF1’26. There's a tall and a short, and basically that is dependent upon the thickness of the carbon fiber. So this is 1.5 millimeter carbon, so we will be using the short ball socket. When installing the ball socket on the torsion bars, I like to put the larger hat side on the same side as the body posts, so it would be facing downward. To install the ball socket, there's a gap. It's kind of hard to see. There's a gap, and to install it, you want to close this gap, put the ball socket into the hole in the carbon fiber, and then this will spring back and lock into place. Some things that can help sometimes, is like a metal plate, something to rest onto. To install these, I like to basically put the closed end into the hole and then pinching the open end together, and then it just sort of goes into place. If this is installed correctly, the ball socket should rotate pretty freely inside the carbon fiber. So this one looks to be installed correctly. So again, with the side torsion link, I like to put the larger hat end facing in the same direction as the body post. And then installing this, I like to put the closed end into the hole slightly, so you can see it's at an angle, and then pinching the open ends together and pushing it down into the hole. So not too tricky once you kind of get the hang of it, but that is sort of a different way of applying a ball socket. Typically there's O-rings or you glue them in place. This way has worked really well for us. To remove the ball socket, typically we haven't had a whole lot of success of saving these. So to remove them, I'll grab like a X-Acto blade and pry under the large part of the hat, and the top hat will rip off and then the bottom half will pull out. And then you just install a new insert. So now we're going to put the threaded ball into the ball socket. So we're going to take two M3 threaded balls, and with the large side facing towards the ball, we're going to go ahead and press these down. So that's it. Should have a good crisp snap. Should be in place. The up and down play shouldn't be too much, but it should be fairly free in this assembly. So then we're going to do the other side. Cool. Yep, so these assemblies are basically done and they're ready to be mounted to the chassis. To mount these to the chassis, I like to use thrust bearings. And these thrust bearing assemblies essentially allow the torsion link to rotate horizontally, but doesn't allow it to translate up and down. And this really helps prevent tweak under hard impacts and is just better for reliability and consistency. So to mount these guys, we're going to use M3x16 countersunk screws, 2 of them. So this car is going to be built for asphalt, so we're going to put this in the 3rd hole on the chassis, that guy, and then we're going to start stacking thrust bearings. So for the thrust bearings, we want to put a washer with the groove facing up, the cage assembly, and a washer with the groove facing the cage assembly. Then we take our side torsion link using the same hole. We're going to slide that over the M3 3x16 screw, and then we're going to put the other thrust assembly on top. So washer with the groove facing upward, the cage assembly, and the washer with the groove facing the cage. So to secure all this together, we're going to take 2 M3 lock nuts and tighten all this down. So you can see it's tight, but this link is still able to rotate around, and then it will use the torsion component of the side link in the vertical plane. So horizontal, it's still free. Up and down, it's using the torsion of the carbon fiber. And we'll repeat the same process for this left side. So in the 3rd hole, we'll insert the screw. Then to apply the thrust bearings, washer with the groove facing up, cage, washer with the groove facing down. We'll grab our torsion bar assembly And using the same hole that we used in the chassis, we'll slide that over the M3x16 screw. For our final thrust assembly, use the washer with the groove up, the cage, and the washer with the groove facing the cage. And we'll lock all that down with an M3 screw nut. You can see for this guy, both of these move really nice and free, but vertically, they're fairly stiff. That's your side spring, is this vertical movement. So that's the side link assembly in a nutshell. For tuning these side links, like I said earlier, I like the third hole for asphalt, the second hole for carpet. Going rearward will induce a stiffer torsion bar because you're making this link shorter, and going to the longer holes, the more forward holes, will create a softer side link suspension. So just keep that in mind, that if you want a softer spring, go forward. If you want a stiffer spring, go back.